And thank you, everybody, for attending today's webinar. I'm going to start off with agenda. I've lined up the following. So we'll go over some architecture best practices. We'll do an overview of what are edge services, since edge services are a collection of a number of services that we have at AWS. We'll go over some of the benefits of using those services in your application architecture. There's a couple of use cases we'll want to go over. We'll talk about how to get you started, because we've got a lot of traditional ways to get started, and we've been developing a lot of new ways for you to onboard with edge services. And then we'll reserve some time for questions and answers. So I'm going to go ahead and get started and just remind the audience a little bit about some best practices for architecting in the cloud. If you'll turn your attention to the Q&A section, we're going to go ahead and post a link to a white paper that I'm going to refer to, which is posted on the AWS website. The white paper is entitled Architecting for the AWS Cloud Best Practices. And really what it does is serves as a reminder for us today to make sure that we are keeping these principles in mind, especially as we start to turn our attention into the edge services. So one, from the best practices paper is keeping in mind scalability, always architecting your applications that can scale both horizontally and vertically. To employ disposable resources instead of fixed servers. It's much better to keep this in mind, and it's one of the key tenets of building a cloud-based infrastructure. Making sure that you use the automation and the automation services that are built into AWS. Automation services include the ability to auto-scale. It also includes the ability to use things like CloudFormation. To introduce automation into your application just increases performance and overall impact of the application scaling components as well. Remember to keep loose coupling involved in application designs to make sure that there aren't too many dependencies or serial dependencies to work in an asynchronous manner when appropriate. To build services and not servers. To deploy databases, whether they are relational or non-relational databases. To keep in mind removing single points of failure. And for us, and from an edge perspective, making sure that you're employing caching. And that's for either static or dynamic content, or even using caching architectures to post content into the AWS cloud. Also, there's always a mention of security and making sure that across the cloud implementation that security is a core component, but also to understand that security is included within AWS and cloud-based infrastructure so that much of the security can be offloaded to AWS. And finally, to optimize for cost. So I'm not going to go into each of those application best practices in depth. What I will do is ask for you to ensure that after this webinar that you do refresh and take a look at those best practices, but keep in mind what we just went through as we talk about edge services. So what are edge services? Edge services are really made up of 5 components. One being at its core, Amazon CloudFront, our content delivery network. And on that, or along with Amazon CloudFront, is Lambda at Edge, which is our serverless compute capability that's been extended to the edge of our network that run on CloudFront edge locations. AWS Shield, which is our managed DDoS protection service. AWS WAF, our web application firewall. And Amazon Route 53, our domain name system. So I'll go over each of these in a little bit more detail. And we'll talk a little bit about how we can use those in our application from a best practices perspective. So let's start with accessing your core infrastructure services directly. So typically, applications have been built with 3 core AWS services: compute, database, and storage. Each of these services can be accessed directly by users, either internal or external, and the application resources are typically made available in any of our AWS regions. What we tend to see now is that, and to keep in mind some of those best practices, is controlling access and allowing even more scalability using edge services. So what this diagram does is it encapsulates the compute, database, and storage services that we have with edge services and allows for those core application resources to be accessed from our edge network, from the largest footprint that we have. And essentially what that does is it adds a couple of elements. It adds security, additional scalability, and performance optimization for your applications. And I'll go through those in a little bit more detail as well. So let's talk about accessing your web applications and what accessing those web applications directly looks like. So it may seem simple. You may have a user here on the left who's connecting via some kind of wired or wireless router and accessing the application that's hosted within AWS. Well, accessing applications really isn't quite this straightforward. There's a lot to it. The route that a user will have to take, or the data will have to take, can traverse many networks to reach the application. First, it'll leave the local ISP and go to the next network, and then on to the next, to the next, to the next. Here I show network A, B, C, D, E, and F, finally reaching the AWS application that's hosted. The paths to and from the application actually may differ. So the request that comes into the application and the response back from the application may traverse different paths through the various networks and finally back to the end user. And that may change on a per request basis. What this does is each hop along the way can add performance and can introduce risk factors to the application communication pathway. And the overall impact is that your application may not be performing optimally. And this is where the edge services come in. What edge services does is it essentially helps to remove a number of these inefficiencies. So you can see from the automation, we had the AWS cloud actually move a little bit closer to the local ISP, or the closest access point that your end user may have to your application. What happens here is that CloudFront is being used, and also Route 53. CloudFront from the content delivery network has edge locations that are closer to the local ISPs, and in many cases may be connected directly to those local ISPs. Route 53, our DNS service, if your domain is hosted with Route 53, is going to hit one of our DNS resolvers and get to the AWS network faster, because you'll end up hitting an AWS CloudFront or Amazon CloudFront edge location. The application then, the pathway to the application, once it is on the AWS network, once it hits Amazon CloudFront, is a lot faster because you're already riding the AWS backbone and you're on the AWS infrastructure. Shield and WAF then can be used at the same application border that you've just moved closer to your end user to mitigate risk and essentially stop any bad actors or malicious types of attacks at the border before it even reaches into the application architecture. Lambda at the edge can also be deployed on CloudFront to add additional intelligence and control for both static and dynamic content, making applications snappier, perform a little bit more dynamic content processing. And finally, what this ends up resulting in is improved performance of the application in general. So hopefully you can see that all the complexities that we had before in terms of a network perspective and mitigating the risks along the way, latency and security, can all be handled and pushed closer to the end user from where the requests are coming from and ultimately where your application content is being delivered to. So let's review some of the benefits of an edge implementation. First, the edge services will create a tight application boundary. So what this means is that while the application boundary has expanded into many edge locations around the world, it's a single service. And that application boundary is now pushed to CloudFront. Then what ends up happening is you reduce the risk surface area just to the edge. And with the built-in mitigations that we have with AWS WAF, Shield, and inherent security protection services on the edge, you're able to mitigate those risks closer to your end users. And so you also improve secure access to applications by doing that, by taking into account that there are controls on the edge that users can, or that developers can deploy to control who accesses applications and from where. Because the applications are being, the application architecture has moved closer to the end user, latency will be reduced and performance will be improved, and the control of the application is also improved as well. These networks are, the content delivery network and the services, the WAF and Shield services in Route 53 are scalable network components. And the best practice of making sure you have scalability and are able to horizontally and vertically scale your application are enhanced by adding the edge service component to it. The other added benefit is that we reduce the total cost of data transfer. And I'll go through some details on how that's done. But keep this in mind because architecting your application for performance is one very important vector, but also making sure you have optimized for cost is another. And a big part of the cost can be data transfer. And edge services takes care of a lot of that component. And finally, there are a lot of visibility components that are available from all the different edge services, be it Route 53, CloudFront with access logs, WAF logs, or Shield, CloudWatch metrics. You can start to see how applications are performing and do very robust application analytics to help change the way users interface with the application. So you get a really good, robust set of benefits that all align directly with our application best practices within AWS. So let's start with Amazon CloudFront. Let's dive a little bit deeper. So again, Amazon CloudFront is our global content delivery network. And it is made up of a large number of servers distributed worldwide that delivers both static and dynamic content, but it also is used to ingest data directly into the cloud using various HTTP methods like put, post, patch, options, or delete. It's integrated with AWS WAF and AWS Shield. Integrated truly in the sense that AWS WAF is deployed at each of our edge locations, and that AWS Shield is also deployed at each of our edge locations. So that's a physical deployment and a logical deployment from a hardware and software perspective. We also have built-in intelligence of Lambda at the edge, moving our compute capabilities closer to end users, and the ability to modify content, modify requests, a number of other use cases we'll cover. There's built-in security features within CloudFront and effective pricing options. So looking at the network a little closer, today, the Amazon CloudFront edge locations are all over the world, and it includes 80 plus locations today, and the edge location count continues to grow over time, and will continue to do so in the months and years ahead. We also have regional edge locations. The regional edge locations are listed here, and they are available to all CloudFront users. They are essentially you can consider them like a mid-tier cache, where the edge locations, the penultimate edge location, are homed into, and then finally those regional edge locations will talk directly to your origin servers. The edge locations include, again, CloudFront, Shield, WAF, and Route 53. So let's talk about the built-in security controls that are available. And this is offloading some of the heavy lifting of security to the edge. And there's really two dimensions that I'm going to cover here. The first is access control, and controlling the access to your content or to the application itself. First, we have the ability to protect or control access to your origin, your AWS hosted origin, your custom origin, by injecting headers and ACLs. So you can have CloudFront inject a header into all requests that go back to your origin, such that that can be used as a verification or an authentication that it is CloudFront that's making the request. Also, you can put access control lists with CloudFront IP addresses such that you lock down access to the application from only Amazon CloudFront or the Amazon CloudFront IP address range. And that IP address range is updated and posted on our CloudFront developer webpage. Finally, we also have content protection. So you can protect who controls which piece of content by signing URLs or signing cookies. These URLs or cookies are customized to the end user. They are valid for a certain amount of time that you specify and valid for a specific IP address. This can help when you have content that has rights restrictions or geographic restrictions. And for geographic restrictions, CloudFront is also built in geo-blocking. So you can either whitelist or blacklist on the country level who can access the content and which content. And finally, if you're hosting content in S3 and have a lot of static objects available there, you can lock down the access to S3 buckets to just CloudFront by creating an origin access identity. So in this way, this is the vector where the built-in CloudFront security controls prevent or help you modify or control access to the origin and the content that's hosted there. Let's look at the other vector, which is the encrypted connections. So locking down access is one thing, but making sure that those connections, once you grant access, are also secure and encrypted. And we do that in a number of different ways. One is we provide SSL and TLS connections, either SSL version 3, TLS 1, 1.1, and 1.2. We have advanced ciphers, 128 and 256 ciphers, DES, SHA, MD5, all available. We also have integration with our certificate manager, where you can procure free AWS certificates to host content within CloudFront, and those certificates can also be used on our Elastic Load Balancers. From an SSL perspective, we have a couple of advanced features that are built in. You don't have to do anything to take advantage of these. We deploy OCSP stapling, session tickets, and perfect forward secrecy. This overall makes the SSL negotiations faster, and the communication pathway between the end user and CloudFront and ultimately the application much faster and reduces latency over time. And also we have protocol enforcement. So you may want to make sure that customers are always accessing your application over an encrypted SSL connection. You can do that with either a half bridge or a full bridge connection. A half bridge connection will be from the end user to CloudFront. The full bridge takes it all the way from the end user into the application through CloudFront and from CloudFront into the application tier. So in this way, you have a full encrypted pathway. So these are the built-in security controls that you have for the edge network. Let's look at performance and scale. Network acceleration is done via TCP optimizations. We have the regional edge caching layer that I talked about, the put and post functions for getting content ingested into the application, lowering the overall latency of the application by doing latency-based routing to individual edge locations. We have granular cache control. We employ things like origin timeouts. So the communication pathway, we can time out if the origin isn't responding in the time period that you want it to, or you want to give the origin more time to respond. We have fast propagation and content invalidations. So getting the content out quickly, getting changes to the configurations out within a minute or less, and invalidating content, very important when you need to take items off the edge. Low latency, high throughput connections end up being your performance optimizations. So from a cost optimization, there are three vectors here. We want to make sure you lower the overall cost. We have three models: on-demand pricing, that's available to all of our customers with our rates published online, regional tiered rates, pay-as-you-go, free tier available. Reserve capacity is a reduced pricing contract that's available on a variable term on a per use case basis. You can contact AWS sales to find out what options are available there. And price classes are optimized cost vectors that are controllable by our customers to determine which parts of the edge network to use at which time. The overall benefits here are that there's no data transfer fees between an AWS origin and Amazon CloudFront. So remember when I said we're going to remove, or we're going to optimize rather the data transfer fees? This is a big optimization piece. So all that data transfer that would normally come from your application tiers in the Elastic Load Balancers, application load balancers, EC2 instances, S3. If CloudFront is being used to populate CloudFront, there's no charge there, and you're only paying for the data transfer from CloudFront to the end location. No charges for any of the regional edge caches, that mid-tier that's available. No charges for the SSL, TLS certs from Amazon Certificate Manager or the shared certs that we offer. You can host your own cert for a low fee. The great thing here is that it's the same network, same rate for both HTTP and HTTPS traffic. The request fees do differ on those two, and they're simple request fees. So that's cost optimization for CloudFront. Now let's talk a little bit about how you can accelerate applications with Lambda at Edge. With Lambda at Edge, you can modify or you can run Lambda code close to the end user using 4 different event triggers. When content comes into the CloudFront Edge, when content is being requested to the origin, when the origin is responding, and when the viewer is responding. So some examples that you can use Lambda at Edge for is event-driven code, header response manipulations. Maybe you want to change the response that the application has depending on the headers that are coming in, or change those headers as they're leaving the application or going into the origin. Authenticate users, redirect HTTP requests to different origins for different types of content based on who the user is. Test your applications out by making A/B tests and changing which viewers get which responses back from the application as you're making changes along the way. Create content. So do smart content assembly. Make content dynamically when the request comes in based on who's making the request. So full body type manipulations. Image service optimization and controlling access to the application as well. So real quick poll question, just from a security perspective, wondering how many folks are using WAF technologies in front of applications to protect them? WAFs, just as a reminder, a layer 7 application packet filtering type of a service. So looking at some of the responses coming in, it looks like there are some folks that are definitely using WAF technologies. It looks like about a quarter of the audience is using some sort of a WAF. About 60%
is not using it, and there's a bunch that aren't too sure, about 20%. So let's talk a little bit about WAF and what we have there and why you would want to use that. So AWS WAF, that's our application level security. And what the AWS WAF does, it allows to block or allow web requests and monitor security type events. This is layer 7 application security. The AWS WAF is deployed at each of our edge locations, also available within, today, 5 of our AWS regions. And there are a couple different components. There are conditions, rules, and rules that go up to make what's called a web ACL or a web access control list. Some things that you can match from a condition perspective are IP addresses, string match conditions. You can prevent SQL injections, cross-site scripting. You can create rules that look at the size of requests and limit, large size requests. You can change rules that allow you to either block, allow, or count requests that come in based on rate. And so number of requests per second or requests per 5-minute period. And these match conditions and rules are reusable not just for Amazon CloudFront, but for also your application load balancers. You create rules, deploy them into the edge locations, and you can have a minute to change or a minute to get metrics back and sample requests. So you can either deploy these web ACLs globally using CloudFront or locally at AWS regions on the application load balancers. So really good practice to ensure edge application security. Let's talk a little bit about AWS Shield Advanced. So this is our managed DDoS protection service which solves really a couple traditional issues that we had seen with DDoS protection services. One is a lot of folks had a lot of operator involvement when a mitigation needed to be initiated with. If you were under attack, you needed to call the operator. Also, most of those operators were rerouting traffic to distant scrubbing locations, which increased the time to mitigate. And AWS Shield Advanced solves these by integrating into the AWS global infrastructure at each of the edge locations at each of our regions, being always on and having fast mitigations without having to route externally to different scrubbing centers. So inline protection as requests are coming into the network. And redundant internet connectivity at each of our AWS data centers to ensure high amount of bandwidth capable of handling the world's largest type of attacks. The AWS Shield Advanced service is available at a low monthly fee across a single account and adds a couple of things. Additional detection and monitoring. You get access to our 24/7 DDoS response team, a team dedicated to working with our customers directly when incidences of DDoS are occurring. We also provide cost protection, economic protection to absorb DDoS scaling costs. The AWS WAF, which we just covered, is included at no additional charge when using AWS Shield Advanced service. Finally, you get a lot of new visibility and into attack detections and mitigations with the CloudWatch metrics that are available with that service. Best thing is, no architectural changes required, near instant on protection when turning on the service, and it's available globally. So finally, Route 53, our global DNS service. So if you don't already use Route 53, you can use it to register and manage domains, manage your hosted zones. We serve DNS queries, and you can use it as a routing service as well to route traffic to AWS resources using built-in traffic flow parameters like DNS failover, geo-routing, latency, and weighted-round routing. So our second poll question, do you think you can use edge services if you don't have cacheable content? And the reason why I put this question out here is because when we look at edge services, at the core of the edge services is our content delivery network. And most people think, hey, I have a content delivery network. It's really only good for static assets, and that's just cacheable. But my application isn't necessarily static in nature. So that's why I asked the question. It looks like most people think, yes, you can use edge services if you don't have cacheable content, and you're right, you can. In fact, many of our customers today use our edge services just to do application acceleration and content acceleration as well. So there's two different cases for dynamic and static content delivery. We have two customers. We have these use cases posted online. You could read a little bit more in detail. But Brightroll, digital advertising company delivering video ads. This is a static use case. They're delivering lots and lots of ads all over the world to their customers directly off of CloudFront. This is video playout. Supercell, a gaming company, worldwide gaming company, is delivering dynamic assets for their games in game when customers or gamers are requesting specific assets and they need to be dynamic or they need to be changed depending on who the user is. Second case is a full dynamic case where the content delivery network is just doing API acceleration. So Major League Baseball, MLB, and Slack are two good examples here where both companies have realized application performance improvements 20 to 40% just by putting CloudFront in front to allow it to terminate SSL connections, to do TCP optimizations, to accelerate the communication pathway between the API calls from their end users back into the application. So using CloudFront almost as a proxy to the application. So you're getting a larger footprint, lower latency, higher impact. All right, so let's sum up. So there are key takeaways from today. Application core services typically include compute, storage, and database. You're already using them today if you've got your application deployed on AWS. The edge services are providing additional value for you. They're providing content delivery networks, built-in security controls, domain name system services, distributed serverless compute. We're providing network scale, performance, and visibility while supporting both dynamic and static content and have a lot of built-in cost optimization. So adding edge services essentially has a number of different ways to improve application performance. And when you look back at the best practices for application design within AWS, you can see edge services impact each one of these. So getting started. So a few simple ways to get started. Obviously sign up for an AWS account. Transfer or create your hosted zones in Route 53, www.mysite.com. Make sure it's hosted in AWS. For CloudFront, you can create a CloudFront distribution via the console or the API. But we've also got some pretty cool tools for you. You can launch a CloudFront template snippet from CloudFormation. So if you go into the CloudFormation dev guide, you can see a bunch of different CloudFront template snippets that allow you to single press deploy a CloudFront distribution in front of an application that's hosted in EC2 or on S3. The WAF, you would create ACLs, associate those web ACLs to your CloudFront or application load balancers. We've also got some really cool pre-configured rules and protections that you can launch, again, with CloudFormation. And you can hit that from AWS, aws.amazon.com/answers and see our pre-configured protections. And finally, Shield. Again, no architectural changes. You basically add your account and the resources you want protected, choose the resources, and you've got DDoS protection.